Let's talk about graphing. We're going to take a look at graphing subsets of real numbers. First, we'll take a look at graphing individual numbers from sets, and then we'll take a look at graphing intervals, and primarily we'll talk about inequalities. But first, we need to talk about the number line. And I'm drawing them freehand, so it doesn't really matter how you represent your number line, but generally you put a 0 in the middle, positive numbers to the right, and negative numbers to the left. Now let's suppose I have a subset of real numbers and I'm going to list some odd whole numbers. So 1, 3, 5, 7, and that'd be enough. Let's just keep it a small set so we can show the graph. So now, because I used whole numbers, they're all positive. I don't need to list the negatives since I'm drawing it freehand. So I'm going to put my 0 over here and just kind of draw it out a little bit. And you don't even need to be this detailed when you're drawing it yourself. Okay, now put dots for each number. And you're done. Now suppose that your subset has some numbers that are not perfect whole numbers or integers, and they fall between. Now, because you're drawing the number line, you can, draw it any way you want. So let's take a look at this subset. We'll call it set B, and I'm going to use some rational numbers: negative 7/3, negative 3/4, and let's do a decimal for 1/3. We'll do 0.3 with a line over it. And let's go ahead and throw in one irrational number, the square root of 2. Okay, now because you're drawing the number line, you can just draw these out the way they are. Now to do the square root of 2, it's somewhere between 1 and 2, so it might be a good idea to go ahead and draw your 1 and 2. Okay, and you need to put dots over each of these. Which I didn't do. All right. Now to talk about intervals, graphing intervals, we need to talk about inequalities. So let's first talk about inequality symbols. First symbol is not equal to. And here's an example. 5 is not equal to 8. Is less than would be our next symbol. And 5 5 is less than 8. Is greater than. Twelve is greater than 3. Now let's throw an equal sign in there. Is less than or equal to. And for this, I want to show 2 examples because there are 2 ways that you could make a true statement. "12 is less than or equal to 25 is a true statement, and 25 is less than or equal to 25 is also a true statement. Okay, then is greater than or equal to. So 5 is greater than or equal to 4, and 3 is greater than or equal to itself. All right, the next symbol is the approximately equal to, so squiggly equal sign. And my favorite example is saying pi is approximately equal to 3.14. All right, let's take a look at some inequality statements so we can graph some intervals. So x is greater than -2. So what does that mean? Well, it means that x is some number that is bigger than -2. And if you think about that for a second, there's a whole bunch of numbers that are bigger than -2, right? So in order to represent this, we have to use a number line and an interval on that number line. Okay, so in high school you learned closed circle, open circle. So for x is greater than -2, you would put an open circle on -2 and shade to the right. Now, in your college math classes, we like to use interval notation, but it really doesn't matter. In fact, in your homework, it uses closed circle, open circle. But you do it the same way, put a -2, but instead of an open circle, we're going to open parentheses on -2, and then shade to the right. Okay, let's take a look at how your homework looks, and I put this in Blackboard, but this is the way it looks freestanding. I use something called MyOpenMath because it's free and it works well. So let's take a look at how to graph x is greater than 1. And you see on this software it gives you closed circle, open circle. So x is greater than 1. We would put an open circle on 1. So click on the open circle and then click above the 1 and it puts an open circle. And then click on the draw a line and you have to click and hold and drag until the arrow appears and then let go, and then it gives you that continuation. And then they want you to write your answer in interval notation, so you're going to have to kind of do both. So open parentheses and put a 1 comma, and then using the drop down menu we can get our positive infinity and close parentheses. All right, for the next one, x is less than or equal to 4. Now this is going to be a closed circle because of the equal to sign. Is less than or equal to 4, we shade to the left. Okay, so interval notation, because we read our graph from left to right, we're going to open parentheses and start with negative infinity, comma, 4, and then close brackets.
All right, the last thing I want to talk about in this video is compound inequalities, and we will be using these two types. This one that I have the word "and" above is the one we'll use the most in this section, and then this one that I have the word "or" over we will use whenever we're talking about absolute value inequalities. The compound inequalities are simply multiple inequalities stuck together in a single statement. Looking at this one here, this is the same thing as x is greater than 5 and x is less than 12. And by that statement you can tell that x lives somewhere between these two numbers. So I'm going to go ahead and throw them up here on the graph. And looking at this first statement, x is greater than 5, we open circle and shade to the right. And the second part, x is less than 12, we use open circle and shade to the left. And then we write our answer in interval notation by opening parentheses, 5, comma 12, close parentheses. Okay, for this other one, it's very similar, but it's already broken up. And if you look at this, you can see that x is greater than -2 is larger than x is less than or equal to -7. So the proper way to write this, and you might want to order them before you work them, would be to write that x is less than or equal to -7, or x is greater than -2. And again, we'll use a single number line to represent this. Here is -7, and here is -2. Because I have an equal to sign, I'm going to use a closed circle on -7, and I'm going to shade to the left because it is less than. And I'll use an open circle on -2 and shade to the right. All right, our interval notation, we read our graph from left to right, so we begin at negative infinity, and we go to -7, and we close brackets because of the equal sign, And then over here, we open parentheses, -2, and we go to positive infinity. Now we need to lock these together, and we do that using the union symbol.